Hi everyone, in this video we're going to talk about how to solve polynomial and rational inequalities. So you'll notice I wrote some steps here. The first thing that you should do is make sure that all of the terms are on one side. That means that one side of your inequality has a 0 on it and everything else is on the other side. Then you're going to factor, if it isn't already factored, and you're going to find the zeros. Then what we're going to do is use test values to find the intervals that actually make it true. And finally, we're going to write the intervals. So let's do some examples to show you what I mean by those steps, and hopefully they will be more clear afterwards. So in example 1, I need to solve this inequality. So what I'm going to do is I'm going to take these terms and move them to the other side. And that's step 1. It says move all terms to one side. Now, the reason I didn't take the x squared to the other side is because it's actually easier to do step 2 if the x squared is positive. So I'm going to just write x squared minus 5x plus 6. Now what I'm going to do is I'm going to factor this. So I need two numbers that multiply to positive 6 and that add to negative 5. So my product is positive 6 and my sum is negative 5. And that is negative 3 and negative 2. Okay, so the zeros are my next step. And I just need to find values for x that when I put them in, I'm going to get a 0 in this section and a 0 in this section. So this 0 is 3 and this 0 is 2. And what I'm going to do is I'm actually going to write a little number line on the side here so I can just keep track of what I'm checking. So 2 was one of those important points and 3 was another one. Those are my important points. Now what I'm going to do is I'm going to pick a value here that's less than 2. I'm going to pick a value that's in between 2 and 3. And I'm going to pick a value here that's more than 3. And I'm going to take those values and I'm going to put them in to my original question. Now you could put them into one of these other inequalities and that would work. I just decided to put it into the original. So I'm going to pick an x value. I'm going to see what the result is. And then I'm going to pick true or false. Okay, so the first x value I'm going to pick, it can be anything less than 2, and 0 is actually really easy to use. So I'm going to use 0. So I get 0 is less than or equal to 0 minus 6. So 0 is less than or equal to negative 6. This is false, so I know that this does not work in my interval. Now I'm going to pick something between these, like 2.5. If I put in 2.5 to my original equation, 2.5 squared is 6.25. And if I put in 2.5 over here, I get 6.5. Okay, this is actually a true statement. 6.25 is less than 6.5, so that's true. So I know the values in between 2 and 3 actually work. Now I'll check the values that are greater than 3. So I'm going to use 4. 4 is greater than 3. So when I put 4 in, I get 16 is less than or equal to 20 minus 6, which is 14. That is false. So 4 does not work. So my interval is just that it has to be between 2 and 3. Now it says less than or equal to, so that means 2 and 3 are included because the or equal to symbol was on that. So this is the interval that would be my answer. Okay, let's do another example. In example 2, we are given this. Now notice, step 1 is already done. All the terms are on one side and there's a 0 on the other side. The factoring is also already done. This is in factored form, so there's nothing to do for step 2. So I just have to go through the last 3 steps. I have to find the zeros. The 0 here is going to be 0 because if this was 0, 0 times all of this would get you 0. Okay, this 0 is 1, and this 0 happens to be 3. So on my number line, I'm going to check out numbers that are less than 0, in between 0 and 1, and in between 1 and 3. Okay, so for something that's less than 0, I'm going to pick, let's say -1. That's less than 0. So my x value is -1. I'm going to put an R here for results so you're not waiting for me to write that out. And then true or false. So I'm going to take my -1 and put it into this equation. And what I get is a 16 right here. Okay. And I say 16 is less than 0. And that is actually false. 16 is not less than 0. So -1 did not work. Next, I'll pick a value that's between 0 and 1. So maybe I'll do 1/2. So x is going to be 1/2 in my next example. And I'll take 1/2 and put it in. 1/2 times 1/2 minus 1 squared times 1/2 minus 3 is actually -3.125. And is that less than 0? Because it says less than 0. Yes, it is. So this one actually worked. And I'll put my check down here because there's not enough room up there. Now I'll pick a value that's in between 1 and 3. I think 2 sounds like a really good value. So when I put in 2, I would do 2 times 2 minus 1 squared times 2 minus 3. And I find out that I get -2. So is -2 less than 0? Yes, it is. Now finally, I have to pick a number that is greater than 3. So I'm going to do 4. 4 is definitely greater than 3. So I'm going to take 4 and put it in, and I end up with 36 is less than 0. And that is false. Now, I really should write 2 intervals because notice it's a less than symbol, which means that although these 2 intervals are right next to each other, this 1 would not actually work because if the 1 was put in, I would actually get 0. And it can't equal 0. It says not equal to. Okay, so I need 2 separate intervals, the interval from 0 to 1 and then the interval from 1 to 3. But 1 is not included. None of these numbers are actually included that I'm listing here because it says that I cannot have it equal 0. And these are the zeros. These are the values that make it equal 0. So this is my final answer. It's the interval from 0 to 1 and the interval from 1 to 3. Now we have one more example. It is a rational inequality. Here it is. Okay. I'm going to follow the same steps though. The first step is to move this 1 to the other side. So I have 1 plus x over 1 minus x minus 1 is greater than or equal to 0. Now the next step is that I have to simplify this. So this is like factoring, and if it's rational and you have adding and subtracting, you need to combine that all into one big term. Okay, so factor, I'll add on simplify here. If you get something complicated, you want it simple. Okay, so I need common denominators. This is 1 plus x over 1 minus x minus. Now I'm going to multiply this by 1 minus x over 1 minus x to get common denominators. Now I'll combine my numerators. The denominator would stay because those are the rules for working with fractions. So 1 minus 1 is 0, and x minus negative x is 2x. Okay, now this is as simple as it gets. There's nothing really to factor here, but because it is rational, I have to double check something. I have to check this denominator, and the 0 of that denominator is going to be one of our important numbers. Okay, so this 0 is 1. That's one of our important numbers, or zeros. And the other 0 is going to be 0 because the numerator would be 0 when x was 0. So those are the two values that would be considered zeros in this equation. Now technically this is just outside of the domain. Okay, so I have to remember that this is not in the domain. So there is no way that I can put an or equal to symbol on this. It can't equal 1, but it could go up to 1. So now we're going to pick some test values. So I had the numbers 1 and 0. So I need something less than 0, something in between, and something greater. So I'll use -1 as less than 0. Let me make my table here. And again, I'm going to put it back into my original inequality. I'm going to go back into the original one. So what I get when I put in -1 for x's up here is I get 0 is greater than or equal to 1. And that is false. So anything less than 0 is not going to work. Let's try something between them, like 1/2. If I put in 1/2, I get 3 is greater than or equal to 1. Now 3 is greater than 1, so that is true, and this will work. Okay. Now I'll pick something greater than 1, like 2. If I put in 2 to my original inequality, I will get -3 is greater than or equal to 1, and that is false. So this did not work as well. So I just need the values between 0 and 1. Now let's think about the symbols we need here. 1 cannot be included because it's not in the domain, so I'm going to put a parenthesis. Now 0, there was an or equal to symbol here, which means that the 0 would work. And that is my interval for this inequality. And that's my final answer. The numbers from 0 to 1, not including 1, but including 0. And that's it for this video. Let me know if you have any questions.